So welcome to this lecture. In earlier lecture, I talk about various properties of ladder operators. Then in this lecture, I will try to calculate the energy eigenstates in position space or evaluation of wave function. Energy eigenstates in position space. In other words, I can say that I'm trying to evaluate or evaluation of wave function So for this, let us proceed as follows. Consider equation A operator is equal to 1 by root 2, it is Q plus iota P, and A dagger is equal to 1 by root 2 Q minus iota P. Here, as we know from earlier lectures, that this P operator is equal to minus iota h cross d over dx, and this small p operator, as we have defined p operator divided by m h cross omega under the root. So if I substitute this value here, then it will become iota h cross negative sign m h cross omega under the root d upon dx, and this can be modified to minus iota h cross into h cross divided by m omega into h cross d upon dx. This will cancel out with it, and it is minus iota h cross over m omega d upon dx. But this is nothing but this is the value of x naught, because x naught we have defined in earlier lecture that it is h cross m omega under the root. So if I put its value here, then it will become minus iota x naught d upon dx. Let me call it as equation number 1, and this is equation number 2. And similarly, let us try to look at another parameter, that is q. Q is equal to x m omega over h cross under the root. Here it is x over x naught, because this is nothing but 1 over x naught m omega over h cross from here. So let me call it as equation number 3. Now, using equation this 2 and 3 in equation 4a, let me call it as equation number 4a, and it is 4b. So using equation 2 and 3 in 4a, so that means this A operator is equal to 1 by root 2, it is x operator over x naught plus iota minus iota x naught d upon dx, right? That's what we are getting. And if I simplify it, then it will become here, if I multiply taking LCM here, LCM will be x naught, and x naught gets multiplied here, so it can be taken outside. So it is 1 over x naught x operator plus x naught square d over dx, and it is 1 by root 2 x naught, and it is x plus x naught square d over dx. So that's what I'm getting. Similarly, so A operator comes out to be this one, and similarly one can derive A dagger is equal to 1 by root 2 x naught x minus x naught square d over dx. Now we have to use these equations to calculate the wave function. Since we studied in the earlier lecture that A0 is equal to 0, so operating both sides with this, then this will become 0. Now I have to substitute their values. So it is 1 by root 2 x naught x minus x naught square dy dx. It is equal to 0. 1 by root 2 x naught, it can be taken outside, and this can be written as x0 plus this is equal to 0. Since this is also a number, this is also a number, so they can be taken outside. So that means 1 by root 2 x naught. Here this x is taken outside, so it is x0 plus, from here similarly I can take these outside, so it is x0, and it will be equal to 0. But as you know that this x0 is nothing but it is the ground state wave function psi naught x. So if it is psi naught x, then I can write down it as 1 by root 2 x naught. It is x psi naught x plus x naught square d upon dx psi naught x. This is equal to 0. So if it is so, that means this x psi naught x plus x naught square d upon dx psi naught x is equal to 0, because this can never be 0. If it is not 0, then this must be equal to 0, right? So from here I can write down expression for this here, is psi naught x, and it is equal to minus x over x naught square into psi naught x, and this may lead to that d upon dx operator can be written as minus x over x naught square. So let me call this as equation number 7. Now separating variables, so to find out its solution we have to separate out the variables. So separating variables, what I will do, it can be written as psi naught x over psi naught x is equal to minus x over x naught square into dx, and its integral, and separating variables and integrating. So if I integrate, then its integral will be natural log of the function is equal to, its integral is x square by 2. So it is minus x square by 2x naught square plus k is the proportionality constant. Now taking exponential on both sides, so if I take exponential on both sides, then it can be written as that psi naught x is equal to exponential of minus x square over 2x naught square plus k, and here it is exponential minus x square over 2x naught square into exponential of k, and let me call it as a is constant. So this equation can be written as a exponential minus x square over 2x naught square So let me call it as equation number 8. Now we have to find out the value of a by normalization condition, because our wave function must be normalized, since psi naught x must be normalized. So therefore psi naught x mod square its integral minus infinity to plus infinity, it must be equal to 1. So let me try to find out this part. So psi naught x, as we know that it is a exponential minus x square over 2x naught square. So now taking mod, so it is a square exponential minus x square over 2x naught square raised to power 2. So it can be written as a square exponential minus 2x square over 2x naught square. These two will cancel out with it. So it is a square exponential x square over x naught square with negative sign. So that means this will become a square exponential minus x square over x naught square dx, it must be equal to 1, and this is a standard integral, and its value will be, you have to remember its value, it's a standard integral, so its value will be root pi x naught. It must be equal to 1. So from here I can calculate a is equal to 1 over root pi x naught whole under the root, or I can write down it as root pi and whole root into x. So substituting this value in equation number say, go back, yeah, substituting this value in equation number 8, so our equation number 8 will become that psi x naught is equal to 1 over root pi x naught exponential minus x square over 2x naught square. So this is ground state wave function, call it as equation 9a. So this is the required ground state wave function for harmonic oscillator, and its plot already shown in the previous lectures. Now let us calculate another wave function, that is psi 1x, and as we know that this psi 1x is equal to bra x cat 0 sorry, not cat 0 but cat 1. So therefore it can be written as, but cat 1 can be written as a dagger cat 0, so that means it is a dagger cat 0. Now let us substitute its value using equation 6, the value of a dagger. So it is x, it is 1 by root 2 x naught, it is x minus x naught square d upon dx, and this is 0 cat, and 1 by root 2 x naught, it can be taken outside, so it is and this is also a constant, so it can also be taken outside. So d upon dx, and here I can express it like this, and 1 by root 2 x naught x minus x naught square minus x over x naught square. Here I have used the equation 7 to write down the value of this operator d upon dx as minus x square over x naught square, right? So I have used that value in this part. Now it is x0, it is equal to 1 by root 2 x naught. So this will cancel out with it, and minus minus will become plus, so it is 2x and psi naught x, and substituting the value of psi naught x here, so 1 by root 2 x naught, this 2 okay, this 2 will cancel out with it, so root 2 will be there. So overall this can be written as root 2 x naught into x into psi naught x, and this is equal to root 2 x naught x 1 over root pi whole root over x naught exponential minus x square over 2x naught square. This x naught and root x naught will become x naught raised to power 3 under the root. So that means putting these two together, this equation will become two over pi under the root x naught cube whole under the root into x exponential of minus x square over 2x naught square. This is the wave function. Let me call it as equation number 1. First excited state wave function for the harmonic oscillator. And similarly, we can calculate another wave function, that psi 2x, and it can be calculated like this. So this is equal to, or this comes out to be 2 root pi x naught cube whole under the root. It's 2x square over x naught square minus 1 exponential minus x square over 2x naught square psi 3x is equal to. Similarly, it can be calculated calculated like this: root 3 into root pi x naught 2x cube over x naught cube minus 3x upon x naught and exponential of minus x square over 2x naught square. And finally, in a similar manner, we can calculate psi n x as xn, scalar product of x and n. That is 1 over root pi whole under the root 2 raised to power n factorial, and 1 upon x naught n plus 1 by 2, and it is x minus x naught square d upon dx, right? D upon dx, then exponential of x square over 2x naught square with negative sign, and let me call it as equation number 13. And here it is whole raised to power n will be there, right? So, and these are the required wave functions. Wave functions for harmonic oscillator. And they are plotted in the previous lectures. So with this, the problem of harmonic oscillator will be finished. So thanks for watching this lecture.